Hello everyone. In this video we're going to go over activity 5.1, and in this case we're using jamovi to do this activity. All right. So our data file here is looking at whether or not students are sort of overly optimistic about how much time it takes to complete a practice test. So everybody takes a practice test over some material, and they are asked to record how long they thought it was going to take that test before they take the practice test. And then we computed here the difference between how much time they thought it was going to take and then how much time it did actually take. So in this case, if they have a negative number, that means that they underestimated how much time it was going to take. And if they have a positive number, it means that they overestimated how much time it was going to take. A 0 would mean that they were perfect. They perfectly estimated how much time it was going to take to do that practice test. Okay. So we're going to do a single sample t, and we want to know whether or not that number that they obtained, the average difference between those two values, is different from 0. So we're going to do a single sample t-test by clicking on the t-test menu and clicking on a one sample t-test. Now we have their estimated minus their actual time here, and we're going to compare that value to 0. So the program here sets up our hypothesis with a test value of 0, which in this case happens to be the test value we're using. That's not the case for all single sample t-tests, so you have to be careful of that, but it does work for this particular problem. Okay. Below this, it gives us a variety of different options for two-tailed and one-tailed test. In this example, we're doing a two-tailed test. Okay, so we're testing to see if our test value is not equal to, our actual sample value is not equal to that 0 value. Okay. In terms of statistics we're going to need the difference between the means, confidence interval, effect size with a confidence interval, descriptive statistics, and descriptive plots as well. Okay. And that's all you need to actually interpret the data here. Okay. So I'm going to move this window over if I can. Trying to, maybe I can't. All right, so in this output here, we have the one sample t-test data. The mean was negative 4.05825, right? And so that's showing us that people underestimated how much time it was going to take them to do that practice test by about 4 minutes. The standard deviation is 12.59 minutes, which is a pretty big standard deviation there in the context of this test that they took. Right? Now we computed t-test to see if this mean is different than 0 by more than what would be expected just based on sampling error. Right? Now the difference we would expect just based on sampling error would be 1.24. So sampling error is a standard error of the mean. That's the typical distance we would expect for samples of this size between that test value of 0. Right? So a computed t statistic. Here it's not labeled t at the top, but off to the side it tells us the student t statistic is negative 3.27 with 102 degrees of freedom with a p-value of 0.00146. Right? So that p-value tells us the probability that I would get a sample mean of negative 4.05825 or a more extreme sample mean if in fact the null hypothesis is true and students are not over or underestimating how long it takes them to take these tests. Okay? So the mean difference we have is negative 4.058 with a 95% confidence interval here of negative 6.52 to negative 1.60. Okay? So we can be 95% sure that the true difference in the population is somewhere between these two values. Okay? The effect size we have computed here is Cohen's d. Our effect size is negative 0.32, which is in terms of our criteria that we're thinking about guidelines for size, that's a pretty small effect. Note that it's not small because it's negative. It's just small because you look at the absolute value there. And that 0.32 is kind of close to like about a 0.2, what we can consider a small effect size. Now, we can be 95% sure that the true effect size in the population is somewhere between 0.12 and 0.52. Okay. Down below, you'll see that you also have generated a graph, a plot of the data. Okay. And so it has the mean and the median plotted for you here on the box plot. Okay. And that is all you're going to need to analyze the data for this activity.